Electrification is transforming vehicle powertrain, helping to cut emissions and improve performance. A range of potential solutions, from mild hybrids to full battery electric, are now available. Some of the largest contributors to CO2 emissions and air quality problems are commercial vehicles, from trucks delivering goods to machinery working on construction sites. In the heavy-duty sector, there are demanding requirements for reliability and cost of ownership, combined with new regulations for mandatory reductions in CO2 emissions. We consider here the different options for electrification in the commercial vehicle sector and how this will help to deliver improvements in CO2 emissions and total cost of ownership for vehicle operators. 48-volt mild hybrid systems are becoming more common in the passenger car space. These systems deliver cost-effective improvements in vehicle efficiency, thereby reducing the CO2 emissions per kilometre of driving. They're often said to deliver 70 to 80% of the benefit of a high-voltage hybrid system, but at only 20 to 30% of the cost. Because of this, there's a great potential for mild hybrid technology in the heavy-duty market as well. Mild hybrid systems use a small electric motor generator to recover energy under vehicle braking and to provide some electrical assistance under vehicle acceleration. In addition, the common engine ancillaries, such as the cooling system, fans, pumps and compressors, are also electrically powered rather than being driven off the engine. Electrifying these components gives significantly improved control and efficiency, as it not only reduces the parasitic load on the engine, but also allows the engine operating temperature to be optimised, something which is critical for the effective operation of exhaust emissions after-treatment systems. In testing, Avid has found our Gen 2 mild hybrid technology delivers up to 28% fuel savings in a typical delivery truck application. In addition, it also facilitates engine stop-start, making it easier to turn off the engine when the vehicle is not moving. Otherwise, operation of a mild hybrid is the same as a conventional diesel. No charging infrastructure, just normal refueling, which is an easy transition for fleet operators to make. Because of these benefits, mild hybrid systems clearly have a place in the heavy-duty powertrain technology roadmap, but they do have some limitations. Principally, the electric motor is not large enough to completely drive the vehicle, meaning that zero-emission operation is not possible. In order to achieve electric-only driving, we need to move to more powerful electric motors, and this requires higher voltage systems, typically between 400 and 800 volts DC. This provides enough power for much larger motors that can fully drive the vehicle or machine, and also recover more energy under braking. However, the high voltage comes at a cost. Ensuring the high voltage systems are safe and reliable adds a significant premium over the 48-volt technology. Delivering zero emissions operation combined with a total cost of ownership benefit is a delicate balance compared to simple low-cost mild hybrid technology. Having an engine and a high-power electrical system does mean that the vehicle still retains the range of a normal diesel. The engine ancillary systems will also be electrified to allow the vehicle to operate as normal with the engine off. Some engine downsizing may be possible with a full hybrid to help offset the additional costs of the high voltage system. High voltage hybrids are very good where mixed use is possible and the required vehicle operating range is greater than can be delivered with a full battery electric vehicle, meaning that fleet flexibility is maintained. The next evolution of powertrain for commercial vehicles is to do away with the diesel engine altogether and have a fully battery electric system. This brings some simplicity compared to a hybrid. We have deleted the diesel engine and all its supporting systems. Some applications are more suited to fully electric than others. Not only does the electric powertrain mean no emissions from the vehicle, vastly improving urban air quality, but the electric motor is superior at delivering low-speed torque compared to a combustion engine. Where diesel engine vehicles operating in urban environments require much more frequent maintenance because of the start-stop operation, electric vehicles do not. This means that as well as improving emissions in the right application, there can be significant TCO benefits for the operator of fully electric vehicles and machines. Of course, in some cities, there are plans to ban combustion engines entirely in the coming years, and in this case, fully electric will be the only option. The key issue of a full electric powertrain being the cost, weight and packaging volume of the required battery pack. That's because of the energy required for a practical range and operating cycle in a heavy-duty application. The next challenge is the availability of sufficient electrical capacity to recharge very large fleets. It's one thing plugging in one truck, but if you've 200 to recharge all at once, this will need a massive incoming electrical supply. This challenge can be partially overcome by using stationary battery systems to buffer the available grid supply in the depot and scheduling charging, but it's still a major challenge for large commercial vehicle fleets. Hydrogen fuel cells are a possible option here. A fuel cell is used to generate electricity from stored hydrogen gas. This currently gives about 4 times the energy density of the current best lithium batteries. The battery on the vehicle can then be reduced in size, but the rest of the driveline will be very similar to the battery electric vehicle. Hydrogen refueling systems can then be installed at sites rather than relying entirely on the electrical grid, with a number of ways to generate and store the hydrogen gas. Hydrogen fuel cells are costly and complex, and generating the hydrogen gas required in the first place does come at a cost. But it provides a clean source of power with some benefits over pure battery electric in some applications, particularly if there are grid limitations or the required range makes a full battery system impractical. As the market moves to electrified solutions for clean air, there will be further developments in powertrain technology. For example, improvements in battery capacity and reducing costs will make the cost of ownership for full battery electric work in a much wider range of applications. At present, there's no one solution that fits all applications, and this is likely to remain the case for the foreseeable future. Avid has been pioneering heavy-duty powertrain electrification since 2005, and we are actively working to deliver solutions from mild hybrid off-highway machinery to battery electric trucks. We have the component and system research and development expertise to support our customers from concept through to our advanced component manufacturing for series production. If you want to find out more about how Avid can help you, contact us today.